Welcome back, everyone. Today we are going to be solving this system of equations using matrices, so let's dive in. All right, the first thing I'm going to do is I'm going to write the equations in matrix form, and that means I'm going to write all of the coefficients and the constants in this matrix. So for the first row, the coefficients are 1, 2, and 3. So I'm going to write 1, 2, 3. Then we have 6 as the answer, right, or the constant at the end. So 6 goes here. For the second row, I'm going to put the second equation. The coefficients for that one are 5, -1, and 1. And then the answer, I erased it by mistake, but it's right here. It's 8. And then our last one is 5, 10, 15, and 30. Okay, so basically what we need to do here is we need to solve the matrix. And so what we're going to do first is we are going to figure out how to make these two numbers here that are below the 1. We want to make these two numbers into 0. And we need to use operations that are valid to be able to use for the matrices. So what I'm going to do for both of the rows, I'm going to multiply the first equation by 5 and then subtract the second equation. So for the new second equation, where it's going to be 5 times row 1 minus row 2. And then for our new row 3, it's going to be 5 row 1 minus row 3, right? Because notice that regardless of what we might or might not get for the other numbers, which we don't know yet, we are going to get zeros in both of these places because 5 times 1 is 5 minus 5 gives us 0. Okay, cool. So let's do that. Let's write our new rows down. All right. So for this one, 5 row 1, right? So 5 times 1 is 5, minus 5 is 0. So 0 goes here. And actually, I should just write 1, 2, 3, 6 here because it's going to be the same thing. Okay. Then for the second one, we're going to do 5 of row 1. So 5 times 2, which is 10, minus -1, which is really like 10 plus 1. So that's 11. So I'm going to put 11 here. And then for this third one, we have 3 times 5 is 15, minus 1 is 14. So 14. Then we have 6 times 5 is 30. 30 minus 8 is 22. So 22 goes here. All right, and then for the next row, for row 3, 5 times 1 is 5, minus 5 is 0, which again, that's what we're expecting. That's the whole point of us doing all of this. Then we have 2 times 5 is 10, minus 10 is another 0, so 0 goes here too, it turns out. Then we have 3 times 5 is 10, 3 times 5 is 15, minus 15 is 0, so 0 goes here. And then, last but not least, we have 6 times 5 is 30, minus 30 is 0. So we have a whole row of zeros. So when we have a whole row of zeros, including the answer being 0, then that means that we have a free variable. Okay, so we'll get more into that in a bit. But essentially what that means is there's infinitely many solutions, that one of the variables can actually be anything that, it can possibly be, and that will always still give us a solution, right? So that's what that means essentially. And if we actually go back and look closer at the first row and the third row, you'll notice that this is just actually the same equation twice, just written differently. If I multiply the first row, all those first terms there, by 5, I will just get the third row. And so essentially, if we look back at the beginning, if we were to, if we look closely and multiply everything here by 5, right, we just get the third equation. So equation 1 and equation 3 are actually the exact same equation, or equivalent equations, I should say, because they do look different, but they are actually representing the exact same plane. So essentially here, the reason why there's a free variable is that there's two planes, right? There's two planes that are actually the exact same plane. And so we need to know, okay, well, where does that plane that, where do these two planes that are actually the same plane, where do they intersect this one other plane, right? And that is, if they're parallel planes, then they're going to intersect nowhere. And if they are not parallel planes, then they will intersect in a line, right? Picture any two planes that are not parallel are going to intersect in a line. And here, essentially, we just have the two planes in the sense that one of our, in that 1 and 3, even though technically it looks like we have 3, if 1 and 3 are the same plane, then we really just have 2 planes instead of 3. Okay, so next I'm actually going to write out the equations once again. So the new equations we would have would just be, the first one's actually the same. It's going to be x plus 2y plus 3z is equal to 6. And then our second equation is that second one. It's going to be 11y plus 14z is equal to 22. Now, in this case, we're going to let z equal to t. And the reason we can do that is because we have a full row of zeros, meaning that we do have a free variable. So what we're next going to do is we're going to substitute t for z, and we're going to solve for what the other two variables would be. So for this first one, we have 11y plus 14t is equal to 22. That means 11y is equal to negative 14t plus 22. And then if we divide both by 11, we get that y is equal to negative 14 over 11t plus 22 over 11, which is just 2. Next, let's calculate x in terms of t. So to do that, I'm going to put x plus 2 times y, which y is negative 14 over 11t plus 2, and then plus 3t is equal to 6. So that means x minus 28 over 11t plus 4 plus 3t is equal to 6. If we get everything on the other side, we're going to end up with 6 minus 4, which is 2, and then plus 28 over 11t, but minus 3t, which 3t is the same as 33 over 11t. And then we're going to get that x is equal to negative 5 over 11t plus 2. So what's our final answer? Well, our final answers are these three right here, right? All of these in terms of t. And if we want to write that in the proper format, we could write it like this. We could write it as the fact that the answer is going to be negative 5 over 11 for x, negative 14 over 11 for y, and then 1 for z times t, plus for x, it's going to be 2 for the constant. For y, it's also 2. And for z, it's 0. And so that's one way we could write out that full solution in a nice, concise way. And we'd also say x, y, z is equal to this. And so right here, this would be our final answer, right? And of course, this encompasses infinitely many solutions here, where t could be any real number. As long as t is some real number, then we're good to go. All right, well, very good work, everyone, and we'll see you for the next one.